Right, if I turn the computer on, load of garbage on the screen, but that's normal, and then hit reset on the keyboard and we get the TANBUG prompt. So that means we're in the monitor now. So in the monitor you can modify memory locations, look at memory locations, enter data into memory, and also run programs from memory. So if we have a look at, let's address 100, so that's saying list from 100 one line, and there you go, 8 bytes. So we've got 57 in 100. So if we then modify and examine, so we're examining 100, so that's got 57, we know that, 57 hexadecimal. We've got FF in there, and then list, you've got an FF, so you've changed that memory location. So you do know now that it's RAM, not ROM. If we put a program into memory starting at 100, so if we put this program, so a 69 is an add with carry, and then I hit line feed, now I can enter another byte, and 1 is 1, and then we do a 4C, and then we do a 0, 0, and the 4C is a jump, 0, 0, 0, 1, so that's a jump to 100 because the order is reversed. It's a little engine processor. So now if we have a look, we've got the 6901, which is add with carry 1 to the accumulator, and then 4 Charlie, which is a jump to 0001, which if you reverse it is 0100, which is 100. So if we run that, it just sits there. Nothing happens now. We're stuck in a tight loop, and the process is just whizzing round and round. We can reset it and check it's still there, and it is. So now what we can do is put the monitor into single step mode, and then we can execute one instruction. Actually, that's executed an instruction at an arbitrary location. You can actually tell it where to run from. So it's now saying that the next instruction to execute is at 102, which is the jump instruction, and the contents of the accumulator are on the end of that line. You've got some other registers that are displayed there. It's 0A. So if we then P is process one instruction, or single step. So we've now done the jump, so we've gone from 102 to 100, and we've done the jump back to 100. The accumulator hasn't changed, it's still 0A. And now we've just executed the add carry 1, so now the accumulator is B, and we're back at 102, which is the jump instruction, which is 4 Charlie, if we list it. There you go, 4 Charlie 0001. If you do a P now, back to 100, the accumulator hasn't changed, do another instruction, and there you go, it's added 1 to it. So that's a very simple program that's been entered into RAM and executed. And you can go back to full speed with an N, and then if you do a go 100, it's stuck in a tight loop again, and I've got to reset it, although I think I can use escape as well to get out. That shows you the accumulator is B4, so if we do another go 100, try and stop it quickly, C4, so it doesn't run that fast, assuming that was one loop. Anyway, that's a very small program, and that's the sort of thing you can do with the monitor. Once you add more features and more cards and more memory, you can do various other things. You can program it in BASIC or Forth, and you can get an expanded monitor which will give you things like cassette load and save routines. So at the moment, if I turn this off, I've lost it. There's no way of saving that. You've got to type it all back in again. So with a system like this with no cassette, you either type it all back in, or you program a ROM and put it somewhere in the memory, replace the monitor maybe, and actually turn the machine into a dedicated machine that runs one program. There is an EEPROM that was done by Electronics Today International magazine, which will let you run Space Invaders on this system. I think you need an extra card for the sound, but with a 2-card system like this you could have a Space Invaders just by replacing the monitor ROM with something else. But that's a simple program.